Welcome to the third session of Advanced Econometrics. Here we're going to pick up another question from the measurement of the heteroscedasticity that we have. If you remember that we did refer to heteroscedasticity in the July to September session of our workshops, where we said one of the very key assumption of the linear regression model is that the residuals must be, or the error terms must have to be distributed equally, or they have to have an equal variance, and the variance should be equalized at each level of the dependent variable that we have. So why we take that assumption is that if you're saying that the Gauss-Markov theorem is going to go stand as the best linear unbiased estimation, as the abbreviation given by BLEV, blue, we say that the coefficients become less efficient or inefficient in explaining the regression model that we have if our data contains heteroscedasticity. That means we are not talking about equal variances, which happens in the case of homoscedasticity. So for heteroscedasticity, what happens is that your standard error, or the kinds of standard error we get, is much more higher. So our model deviates a lot from the real world zero. In that case, you can say that this could become an enemy for our regression analysis, and that's why the assumption was made that the equal variances must be there. What this actually leads us, if let's say that your data contains a good amount of heteroscedasticity, is let's say 50% of your data or 60% of your data contains that, then there is a good chance that you will be making a type 2 error. Remember, we also dealt with type 2 error, where you might not reject the null hypothesis, even if you go for a much more relevant measurement of the standard errors. All right, so that is a type of error you can make. So in that case, today's question was picked up from that topic only. So here, if you see, we have taken a question which states that measure whether the collected samples of the raw data over 5 years equity prices of BPCL, Bharat Petroleum Corporation Limited, and the Hindalco contains heteroscedasticity. They have given a background as well, where they've said that use regression analysis Breusch test. So this is a quite popular test used mostly to the time series data, where you have big data sets and you go to test before you go for regression modeling, and just to recheck given the size of the data that you might have. So Breusch test helps initially to identify heteroscedasticity, although there are more different ways. We might go to them in a different workshop. All right, so the data is collected over 1000 points of price movement. All right, so if we just move and go to our data set here, see, this is a kinds of data we are provided. Here we have raw data over 5 years equity closing price. You see here, we have the dates, 5-year dates. We have almost around 1000 entries, so it's a quite big size data we have. And then the Hindalco part in the first column, and the second column the BPCL and the market as well is given us. So when you are dealing with equity prices, it's better that you keep the market closing prices within the sets of data that you have. So first thing first, we're going to do, we have to go for a Linus function. Before that, we need certain daily returns. So we have to process the closing prices to the kinds of return we can see, so that we can communicate that to the regression model, and then finding the subsequent expected values for the targeted y variable. So in this case, we have to target a dependent variable that is gonna be work as a vector for us. So first we can take that as let's say Hindalco. All right, so we need the daily returns. To calculate the daily returns, just separate and process the data in a different table. Here you write just H, the keep a cell break here, give a cell break, and then here put equal, select the previous day price, or which is this one, 29, and then select the present day price divided by the present day price minus 1. Just hit enter. See, if we have the daily return of the data that we have. All right, so what we did here, actually we did take in yesterday's price, we divided by today's price and minus 1 from there. Now if you just double click here, we will have all our daily returns from the Hindalco dataset. All right, now we also want the returns of the BPCL. Come to the third cell here, and then type equal, select the previous day and divide it by the present day and minus 1. Okay, just hit enter, and double click to get all the daily returns that you have in your disposal. All right. Now we also need the X variable, that means an independent variable. Nifty 50 from here, and similar to the HINDA and BPCL, just put equal, select the previous date divided by the present date minus. All right, hit enter. So we also have the returns, daily returns that we want. All right, now just format it a little bit. So we have put the metrics that we wanted. So what we have to do now to find out the expected values. We need the expected values for the Hindalco. That means this is our targeted dependent variable. All right. So we want to see there that if after the measurement we can say that whether there exists heteroscedasticity in our data or not. So to simply go for a linear regression, we need to use the Linus function. Right? Use the Linus function. Just put equal LINEST. Before that, what I suggest is that if you have an old version of Excel, just select the 3x5 category here, metric cells here, and then just put equal Linus. Open the argument here, then put our Y variables, that is the dependent variable that we have. So all the Hindalco price changes are there. Then put a comma, then select all the independent variable that we have, which is just select Control Shift right, and then hit down. See, all the X variables also, which is our beta 2 and beta 1, which is considered as the volatility of the BPCL company and the volatile nature, daily volatile nature of the Nifty 50, that how much the market moves in different directions in every day. All right. Okay. So this also gives you the riskiness of your daily riskiness type of stuff as well. Okay. So just put a comma. Now put 1 for the constant and also put a comma and 1 for the additional statistics that we have here. All right. Just close the argument, Control Shift and enter. See, as it's a matrix multiplication formula, you have to hit Control Shift enter. All right. So we have the values for the linear regression that we have here. We have the coefficients, the standard error for Nifty 50 coefficient, the let's say this is the beta 1, the beta 2 values. All right. And it has appeared in the reverse order as usual for the Linus function. Okay. So now we can find out the expected values here. Just put a equal sign here. If you remember, we first select the alpha value that we have here, which is the constant. This value here. Then we want to lock this set as we do not want it to move. And then if you hit plus, we also need the beta value of the first volatile variable that we have here for the daily returns, which is BPCL. This one we also want to lock its cell here. This dollar sign would be here before the column number. All right. And then we multiply the BPCL coefficient by the respective return that we have here, which is the daily return of this minus 0.35. All right. And just the plus sign here once again, and then take the coefficient of the market volatility. So this is the market return coefficient, and again we will put a dollar sign for the coefficient here, and then multiply this value with the respective market return that we had. All right. Now if you just hit enter, so these are our expected values here. Just double click here. So we have received all our expected returns. So just click on this overall cell and make it percentage. So we want to say, all right, we can as we have the expected values of the for the Hindalco stock, we can also go for find the residuals of this. So for that we just need to put equal here, and then we have to subtract the actual output, which is for the first day return was this, and what our expected values is. So we subtract the expected number from the main real number that we have here for Hindalco. All right, subtract it from this. You just hit it. So we have our residuals just appeared in seconds, right, for all the data. Now as we have our expected values and the residuals, we can go on finding out if our data may or may not contain heteroscedasticity. So before that, we also just have to make sure that we find out the value of the squared, the residuals into the squared value. So we're going to use them for the regression, right? So just write SQAR residuals here, squared residuals here. Just now in this cell. So to most of the time we deal with squared residuals that we have. So we take the square of the disturbance term that we have here. So this will give us the variance of the residual terms that we have. So we will only use squared residuals for further testing and so on. So just put equal here and then select the residual here and the power 2. Just hit enter. Just double click on this and make it 3 decimals. Alright. So this is giving us the volatility of the error term or the disturbance term that we have. Keep in mind. Okay. Now we let's say this was our OLS model here, and now we're going to construct the Breusch test here. All right. For that, we just have to format our table. Now to run the Breusch test, I have reformatted my sheet a little bit, as I need all the data in the subsequent cells. Otherwise, the regression will not work. So, for example, all the data now are in the parallel cells or parallel columns that we want. We also can bring the residual cell. Just hit Control Shift down. We also can bring this just beside our this data that we have here, right? The Nifty 50 and the BPCL, that the actual regressor that we have. We can bring it to this part here. We have BPCL here, Nifty 50 here, which is our regressors, and then we have the squared residual term here. Okay. Now what we want is that we can just select the 5x3 array here. All right, for the matrix multiplication function. Now, if you just type equal LINEST, open the argument here and select the y variable, which is in this case the dependent variable is squared residuals. Just Control Shift down and put a comma here, and then select the regressors that we have, which is the BPCL data and the Nifty 50 data. Just click Control Shift down and select all the X variable, which is the market volatility and the value of the daily return of the BPCL. All right. So if you just put a comma, then here, then put 1 for the constant, again comma 1 for the additional statistics. All right. If you now just hold Control Shift and hit enter, see all the values have appeared here. Now by just looking at this data here, we can't say too much about the relationship. So although we can see a very small kinds of effect of the Nifty 50 variable we have here on the error terms. For the BPCL as well, we have a negative relationship as well. Okay, and this is the degree of freedom that we have. Now to check for the significance of the Breusch test, there are different ways, but the traditional method is to find a joint significance of the market volatility and the regressor BPCL here. So the single company volatility coefficient that we have. So to test it, what we do is that we find the F stat, then we also calculate the p-value corresponding to this. Also, we're going to need the chi-square, all right, and the p-value of the corresponding chi-square. So this will tell us that whether we can go for rejecting or just not rejecting the H0, which means that there exists no heteroscedasticity in our model. Or if we have to take the other way around, which is there exist unequal variances in our distribution. All right. So for the F stat, so we have our R square value here. This one R squared. Now for the F stat, we just put equal. We take the R squared number of the auxiliary regression that we have. That means this is the additional regression we have got after the main OLS to check the or to diagnose our data that we have for heteroscedasticity. All right, and then we just divide it by 1 minus the same R square that we have, and we will multiply it by, just put a bracket here for the 1 minus the R square value, and we will multiply it by the degrees of freedom that we have here, in our case 967. All right, and then we'll have to again divide it by the number of explanatory variables that we have used, which is 2 in our case. This parenthesis will be this parameter will be 2 specifically. All right, because we have Nifty 50 as a explanatory variable and the BPCL. Right, now if you just hit enter, see we have our F stat value so high. All right, this is on percentage. I'll just change it to general. All right, so it is 13.99598 and something on. And for the p-value also, to check if this is significant or not, we also need the p-value. Now the most instrumental way to find the p-value or the significance of the f-test that we further clarify with the p-value is the traditional method to use equal f-dist function, f dot dist dot rt, and then open the argument here. That's how we call the f value for the f statistics. Right, here just select the f stat value, put a comma, and then the number of explanatory variables that we've used, which is 2, comma once again, and the degrees of freedom that we have, the total number of that is 967. All right, then if you just close the argument, if you hit enter, and if I just make this percentage, so it is the value is much lower than 0.05. What does that tells us? It says that the relationship that is shown here, let's say from the Breusch test, is that there are very small relationship exist, positive relationship exist for the Nifty 50 that is going to impact the data that we have in the Y category, and there is a bit negative relationship. A very simple hint is given here is by the negative sign of the BPCL company. So that means as BPCL goes up or the Hindalco goes up, the BPCL likely to see some negative impact on its prices. All right, okay. That means there exists some linear relationship with the Nifty 50 of the market volatility that we have with the Hindalco category that we have taken as our Y1 variable, which is the dependent variable. And what decision you can actually take that whether or not we have heteroscedasticity in our model or not. Before we move further, let's calculate the T-stat also to be much more sure that how we're going to put the observation on the data. To do it, just put equal here, take the first coefficient, subsequent coefficient here, divide it by the standard error, hit enter. We have positive T-stats, and also we need the value for this T-stat, which is equal, just use p dot dist dot copy in the argument here, take the absolute value of this T-stat, close it, and then put a comma, and then multiply, and then take the degrees of freedom, which is this one, 967 here in our case. Close the argument, hit enter. We'll likely to get a smaller number here. So the p-value is very small. Here also the value of this, and this is taking the wrong value here. So this will be this one. Okay. For this one as well, it has taken the wrong value here. It should be this one. Enter. See. So what does this portion is telling us about the data here? First, if you concentrate for the Nifty 50 column here, the T-stat is much higher, p-value is very low, lower than 0.05. That means this relationship shows a certain significance on the residuals that we have. All right, the market returns, although the impact is very small. Looking at the coefficients, you can tell that it's less than 0.0056, around something, because this is multiplied with the actual return that we have. All right, then you have a negative impact, just hint for the BPCL, but you can say that okay, it is under 10%, so there has a good amount of hint that we wanted from the BPCL category, that it is giving a negative hint towards the residuals or the squared residuals, that is our dependent variable here. Remember, we have used the squared residuals here. This is the volatility. You see the residuals that we get from the Hindalco. This one, we squared them and then we brought them into this column here. All right, so we are using the squared residuals here. So the impact is also significant at 5%. This is at 1%. This is also at 1%. Now this impact is very small. Looking at the coefficients, you can say it has a negative sign. That means we are saying a negative relationship exists. Right. So it is not directly just linear and positive. So we have to explain it further. For this, we also want the chi-square, how we calculate that for the final decision making, that how we will finally explain the hypothesis that we have. The chi-square would be the r-squared value here, and multiply it with the number of observation that we have. So this is the chi-square value, and for the p-value, to find the significance of the chi-square, if it's significantly giving the number above the critical value, for that we need to find the p-value as well. For this, just put equal phi sq dot dist dot rp, fill the argument here. First select the chi-square stat that we have calculated from the model, and then put a comma and the degrees of freedom, or the so here the degrees of freedom will be the number of explanatory variables that we have used, which is 2, right? So 2, close the argument, so hit enter. See, this value is also very much significant. That means this is much lower than 0.05. This is also saying that we can indeed reject the null hypothesis, and we can say that so if we just write down, for the H naught, you write error variances BARI, error variances are all equal. That means homo is present, and our data does not deviate from the assumption. And for the HA, which is the alternative hypothesis, error variances are present, and heteroscedasticity is present. All right. So how do we go and accept or reject this hypothesis that we have here? We just highlight this through here. Now, just concentrate again. I'm telling you that if you are finding it a bit troubling to understand the logic, my suggestion is that you go and study again, revise the theories that we have done. So what we did properly, if you understand that, we first look at OLS. All right, we compared two regressors, which is the market volatility value, the per day return, and the BPCL with the targeted dependent variable that we took to analyze the heteroscedasticity. Now, to diagnose our data was much more important than the regression. That was the motive of the model that we have got here. Okay, so there we took the values we could, but also you have to see that this BPCL part is consistently giving you a negative response. That means that all the F-stat and T-stat that we have bought are actually significantly giving us some statistically significant results. That this gives us some linear response, although this might not be a significant impact. So even if we find the heteroscedasticity in our data, the impact of this is very small. Okay, all right. So you just can see the coefficients and the kinds of negative relationship here. So we can also go for a different type of analysis as well for heteroscedasticity for this particular data set, but we have to provide a decision. Now, if you see that this is significantly giving you a statistically reliable decision, then you say that we reject the null hypothesis. We might also go for much more broader analysis of the heteroscedasticity data that we have here, if it's not clear from the data. But here, if you can see, we have get our chi-square value much higher and very much significant. That much some impact it will bring. All right, some impact, some variances with the reference data that we have shows some linear relationship in the data that we have. So we actually can find some heteroscedasticity in our data, which is the error variances are present. All right, and we reject the null hypothesis that error variances are all equal. It is not all equal. It is showing us a statistically reliable number that there might be some differences in the relationship that we have got with the squared residuals that we had. Squared residuals of the Hindalco data, which is here. This is return, daily return, and then we process this to the regression model, and we saw that there might be some relationship exist, but this is avoidable. This is very small. We can also see the impacts that we have got from the coefficients of the relationship that we have created with the volatility of the Nifty 50 value, this beta 2, and the BPCL beta 1 of the single company volatility. Right? So I hope this way you can make a lot of decisions easily with the big set of data that you have. And again, when you have bigger sets of data, the decision making will become complex. How do you reflect your observation? I haven't talked about the assumptions that I made about the constant. So I took these classes that how you assume what for the constant and for the error terms are important for your data. So here we are all dealing with the variances in our error terms. So that means our data shows some relationship or some hints for the heteroscedasticity present in our data. All right. So I hope the demo-free classes are having a good impact on your practical sense to the interview questions that we are going. Now, for this case, that our decision is that we have rejected the null hypothesis and we've said that error variances are present in our data. All right, so this is what our interviewer wants us to find. All right, I hope you will attend the January to June workshops as well. There we're going to pick up other advanced econometrics topics that you can use into your likely industry and skill up your next data analyst job. Thank you so much. Hope you all spend a very nice year ahead, and I'll see you from the next sessions. Thank you so much.